Supreetha. Welcome to my math class. So what did we study in our previous lectures on limit? We studied about, yes, the concept of limits. We studied the sandwich theorem. And then we studied about what happens to the function sin x divided by x when limit x approaches 0. What happens? We would get that would be equal to 1, right? What would happen to sin x divided by x if x is approaching to infinity? We saw that in the previous lecture, right? We would get 0. So you should have to be very careful in your exams. Yes? And then what did we study? We studied about left hand limit and right hand limit. Yes? If they are equal, limit exists. Yes? Okay. So we solved some problems. Yeah. So in this video lecture, let us study the proof of this, what I've written here. Yes, that is limit x tending to 0, 1 plus x to the power 1 by x is equal to e. This is equal to limit x tending to infinity, 1 plus 1 divided by x to the power x. So first let me prove that this is equal to e. For that, let me take this term. Yeah, let me write that down. Say y is equal to, okay, I'm taking that y is equal to limit x tends to infinity. So I would have to, like at the end, I would have to approach that y is equal to e, right? We would have to prove this is equal to e. Yes. So now let me apply ln on both the sides. Yes. Ln y is equal to ln limit x tending to 0. Yes. 1 plus x to the power 1 divided by x. So now, if you take ln x, yes, the graph of ln x, how is the graph of ln x? Can you recall? If you can recall the graph of ln x, it looked something like this. Agree? So you see that this is continuous, right? There are no breaks. It goes like this till the infinity. Yes. So since it is continuous for positive integers, I can write it as limit x tending to 0 ln 1 plus x to the power 1 divided by x. Okay. So now I have ln a power b. Can I write it as b ln a? Okay. So yes, I would get limit x tending to 0 1 divided by x into ln 1 plus x. What next? You see, this is ln 1, 0. Yes. And if I apply the limits, I would get ln 1, which is 0, divided by 0. It is an indeterminate form. So let me use L'Hospital's rule. Yes, what is L'Hospital's rule? You would have to differentiate the numerator with x. That is, differentiation of ln x with respect to x is 1 divided by x, right? So I would get 1 divided by 1 plus x divided by differentiation of x with respect to x is 1. Now by applying the limit, I would get 1 divided by 1 plus 0, which is equal to 1, right? So we arrived at ln y is equal to 1. So can I write it as y is equal to e? How? Can we write inverse of ln function as e? Yes. So from y is equal to the LHS term, we arrived at y is equal to RHS term. So we can directly write it as limit x tending to 0, 1 plus x whole power 1 by x is equal to e. Okay. Now let me take this term. Yes. Okay, so that was limit x tending to infinity. You would have to observe it very carefully if you're using any terms or any expressions in your problems. Okay, here we have x tending to infinity, but here we had x tending to 0, right? So let me write this. Limit x tending to infinity, limit x tending to infinity, 1 plus 1 divided by x whole power x. Yes, so again I'll be taking this as y. I'll apply ln since it is continuous for positive values. I'll take that ln inside. Yes, then what would I get? I can write it as x ln 1 plus 1 divided by x. Yes, now you see that what if I apply the limit? What would I get? Ln 1 is 0. Agree? Ln 1 is 0. X is infinity. So isn't this a type of indeterminate form? 0 into infinity, can you recall? Yes, so this is an indeterminate form. Can you apply L'Hospital's rule for this? No, right? L'Hospital rule we can apply only for 0 by 0 form or infinity by infinity form. And this is none of these. Yes, so let me first try to reduce this to 0 by 0 form or infinity by infinity form. Okay, so that is limit x tending to infinity. Yes, I can write it as, let me take this x to the denominator, x inverse, or let me write it as 1 divided by x. Okay, now if you apply limit, what would you get? I would get ln 1 is 0 divided by 1 by infinity is again 0. So now let me apply L'Hospital's rule. Okay, so what would I get? On differentiating the numerator, I would get 1 divided by 1 plus 1 divided by x. Yes, so I would have to differentiate 1 divided by x, right? What is the differentiation of, let me say, x to the power minus 1, which is nothing but 1 divided by x, right? What is, in general, what is the differentiation of x power n? So differentiation of x to the power n is equal to n x to the power n minus 1. Yes, so differentiation of x to the power 1, okay, differentiation of x to the power minus 1 with respect to x is equal to minus 1, that is n, to the into x to the power n, that is minus 1, and in the formula we have another minus 1, both together is minus 2. Yes, now can I write this as minus 1 divided by x square? Yes, x to the power minus 2 can be written as divided by x square. Okay, so yes, I would have to write that over here, right? So even in the denominator we have differentiation of 1 by x, so I'll write it as 1 divided by x square. So these both terms gets cancelled. Agree? So what next? Let me apply the limit and check what I would get. I would get 1 divided by 1 plus 0, because 1 divided by infinity is 0. So I have 1 over here. I have ln y is equal to 1. So can I write it as y is equal to e? Yes. So we've studied how we got it as e. Okay. So now you can observe that You can also write this term as limit x tending to infinity. Let me take the LCM over here, that is x plus 1 whole to the power x. Okay. So yes, let me solve a JEE problem over here. Okay. So this is the given question. Let me write it here. Solution. Okay. So we have limit x tending to infinity. Yes, x plus 1 divided by x plus 2 whole to the power 2x plus 1. I can write this as limit x tending to infinity. Yes, 1 minus 1 divided by x plus 2. If you ask me how I did that, let me take the LCM. Yeah, what would I get if I take the LCM of this? I would get x plus 2 in the denominator. Yes, I would get x plus 2 over here minus 1. What is 2 minus 1? That is x plus 1 divided by x plus 2. Yes, which is this term. Okay. So now we have limit x tending to infinity. Yes, 1 plus, let me write it as 1 divided by minus x plus 2. Okay, to the power 2x plus 1. So you see that formula. We had 1 plus 1 divided by x. So the limit over here is infinity. So let me observe this formula. Yes, it is 1 plus 1 divided by x to the power x. So this x and this must be same. Agree? This x and this x. So here we have minus x plus 2. Yes. So let me multiply and divide minus x plus 2 in the power. What would I get? I would get limit x tending to infinity. Okay. 1 plus 1 divided by minus x plus 2 to the power minus x plus 2. Yes. Whole to the power 2x plus 1 minus, we have a minus, divided by x plus 2. Okay, so here it would be plus because in the formula we have positive x, right? We have a positive x. So now what is 1 plus 1 divided by x to the power x when limit x is tending to infinity? It is e, right? So let me write e over here. In this place I would have to write e. Okay, limit x tending to infinity. Yes, e to the power, in the numerator I am taking x common. So I would get 2 plus 1 divided by x divided by 1 plus 2 divided by x. Yes, x and x gets cancelled. Okay, so what is this now? Okay, let me write e a bit bigger. Yeah. Okay, so 2 plus 1 divided by infinity. 1 divided by infinity is 0. Yes, so this is 2 itself. So I would get 2 plus 0 is 0. In the denominator, 1 plus 0 is again 0. Okay, so I would get limit. Okay, no limit because I'm applying the limit, right? X tending to infinity. So I would get minus 2. Yes, because 2 plus 1 by infinity divided by 1 plus 2 by infinity, right? So that is 2 plus 0 divided by 1 plus 0, which is nothing but 2. We have a minus sign over here. Okay, so do we have this option here? Yes, so the correct option is B. Okay, so what did we study today or in this video lecture? We studied about, we just saw how was limit x tending to 0, 1 plus x to the power 1 divided by x is equal to e, and that is also equal to limit x tending to infinity, 1 plus 1 divided by x to the power x. How did we start the proof? We took limit x tends to 0. Yes, the given question. We applied ln on both the sides. We used some properties of ln and we arrived at 0 by 0 form. Yes, and then using L'Hospital's rule, okay, we got 1, that is ln y is equal to 1. So we can write it as y is equal to e, because anti-ln is what? E, right? So yes, in the similar way, yes, we solved limit x tending to infinity, 1 plus 1 divided by x to the power x. So here we got L'Hospital's rule. Yes, we got 0 to infinity form of indeterminate. Okay, can we use L'Hospital's rule for 0 into infinity? No, right? So we first simplified this. We brought that into 0 by 0 form, and then we applied L'Hospital's rule. Yes, and then we solved a JEE problem. Okay, so we reduce the given equation in the form of 1 plus 1 divided by x. Okay, 1 plus 1 divided by x to the power x, and we substituted that as e, and whatever we had in the numerator we simplified it, and then we arrived at minus 2, which was option B. Okay, that is it for today's class. Thank you.